Let's begin. So today is my first of the 2025, so Happy New Year to everyone who joined and who will watch this YouTube video. As they say, how they say, hit like and subscribe in those YouTube videos. So for today, I kind of got inspired by two recent issues on the H5Pi GitHub repository. They've been submitted, I think, by the same user very recently, a couple of weeks ago, max. And I thought that these kind of issues, at least the first one that we're going to talk about, I see frequently enough. So I think that it's something that should be talked about, at least mentioned in some way. And so why not now? And I asked our HDF software architect, Neil Fortner, to join me and help me not say wrong things. And so I'll just do some intro and then see how it goes, but basically it is more like a discussion than anything else. So I will share those two issues as long as I find, yes, I think this is the safe window to share. Yes, so this is the first one. And don't worry about the H5Pi specific things, obviously. We're going to talk strictly from the HDF5 library point of view. But generally, every now and then, there is a user who says, well, my HDF5 file has thousands upon thousands of groups in it, or data sets in those thousands of groups, and the performance takes a hit at a certain number of these groups, or the numbers of data sets per group. And why is that? And things like that. So I wanted to, if we can talk about what is causing these things, and is there anything people can do to at least reduce the performance impact in such cases. And this issue, again, as I say, he provided a lot of benchmarking, but from the Python side, so we don't have a pure library case, at least not here. But there was a very old issue here, as you can see, from 2018, when, again, the same kind of problem was detected, where there is a lot of groups. And I think they're even here kind of measuring them, and then suddenly beyond a certain number of groups, the things really start to go sort of south. And so that's the first topic. The next one, is that the only one? Yes, let me see, writing, that's the one. Oh, yes. This was the next issue where dataset chunk caches are involved. And the person who reported the problem was an interesting use case. He is doing some kind of AI training, and their data is in HDF5 as far as I can tell. And they have a lot of data sets in this file, around 1 million, which kind of thinks that this is exactly the same type of file mentioned in this case, because this file is, also 1 million data sets. And so this person says that because of the dataset chunk caches, they think that they are hitting the out-of-memory errors on their computer. And there were some questions about what can be done, and I thought maybe that's another topic that we could sort of visit today and mention some things. So that's the general outline of this today's session. And so I would basically pose a wide question. First of all, how many groups in a file is really good or bad? Is this like a good practice or not? And if people really need to store or have so many groups or a lot of data sets per group, is there anything that the library can do right now to sort of help the problem? So Neil, if you want to help me here.
All right, so the most important thing for if you have groups with lots of links in them is that you want to use the new file format. So you want to use the, I'm not sure the H5Pi routine, but the In C, you want to call the HFP set libver bounds, and you want the low bound to be at least 1.8. The normal recommendation is just latest if you don't care about, backward compatibility of the file, because with the 1.6 and below file format, the link names are stored in just one single block of metadata in the file, and that block can get very, very big for groups that have lots of links. And once it gets big enough that the metadata cache doesn't want anything to do with it, then it can really slow things down, because that block of metadata has to be loaded and reloaded every single time, because the metadata cache won't hold it. So that's the main thing. You can also look at the, once you're set to the new file format, you can also look at the metadata cache configuration. You can increase the maximum size and the size increment threshold and some other things. And that may give you some additional performance. I know there have recently been some reports that even with, at least with the new file format, that it still slows down, that in some cases you can still get better performance by, making, instead of having just a flat single group with lots of links in it, sort of adding tiers. So sort of essentially making your own tree structure with the groups. I'm not sure exactly why that is, so that would be something worth looking into. But for right now, if you haven't set the new file format, that is definitely what you should do. You should be able to get much, much better performance with lots of links with the new file format.
I'd also suggest setting the B-tree fan out very wide, make the B-tree nodes quite large so that you have many less accesses to get down through the lookups on the heaps for the links.
Yeah, that could also help potentially.
So if we are chasing these things on our documentation, just for the sake of this kind of, let me see, I have to reduce my window here. So what are we talking about here? H5, is it P? Set something?
Yeah, H5P set libver bounds, LIBVER.
Okay, that's here. That's for the, and I know this is the right one. Yeah, so this is the one to set the versions of the library that you talked about.
Right. Yeah. So the low setting should be set to at least 1.8, and you can just set it to latest. Is general recommendation.
So that's the one here. I can only add that H5Pi does support that. I doubt that the person who is reporting this was creating this file, perhaps, maybe, but H5Pi does support this when creating the file. But I always also want to say that most people I interact with, they are just default setting kind of users.
Right.
They just, whatever is the default of the library, that's what they go with. So I would guess that this file is probably 1.8 and then whatever is created with, but I don't know sure. Now, for what was Quincy saying, what is that one? Does anyone know?
That one's called set underscore SYM symbol underscore A.
Yeah, and that applies to the new file format too.
I'm uncertain. I was just looking at the docs and I was about to dive over into the code because I'm not entirely sure. It should, I would think.
So which one are you talking with, IC or ELK? Which one of these two should be modified? The table node size?
I would bump both, but...
Okay.
Let me double check to make sure that I'm not... That's only sometimes for the other...
So while we're checking this, I also want to mention the following. Typically, when I see these cases with a lot of groups, is because essentially those groups store some kind of data in them. There's certain data that's sort of encoded in group names. And that's kind of, I'm not a big fan of that. I'm thinking if the data is data, then keep it as the data should be. which is like an HDF5 dataset. But I kind of understand people why they choose the groups, because it gives them at least some kind of a querying capabilities to go to some parts of the data by relying on the HDF5 native path name resolution. And so that's kind of a yes, but I think if you have a lot of groups, that's probably, and each group name is some kind of data that's much more efficient. I think if that data was put in some HDF5 dataset, and then if needed be, you use the object references to these HDF5 datasets instead of the groups. But anyway, I just want this to throw out there and see if anyone in the comments criticizes me for this statement. But
I'm also looking through the code to see if I can figure out if that applies to the new cell groups.
Yeah, it doesn't look like it applies to the new B trees to me, unfortunately. So maybe there's something else. I thought we had another way to make the.
All right.
I would also maybe suggest setting the alignment and making the metadata blocks in the file bigger, because you're going to have a ton of B tree nodes. That would be.
You mean the good old metadata block size or something like that?
Right, set alignment and set meta something else.
I think I know that metadata thing, even me. Metadata block size.
Right.
There you go.
Yeah, because when you get these groups with a lot of links in them, you're just going to have a lot of metadata in order, you know, B tree nodes and whatnot.
So with this metadata block size is bigger, what it means is that the library is not going to go and read the smaller metadata blocks in the file when chasing up these links. Is that basically what you're implying?
It's going to aggregate them more locally within the file.
Yes.
Yeah.
And potentially in enabling the page buffer might help.
Yeah, you can see that too.
Yes, page buffer, or making, well, page buffer is only going to apply if the file is with the page aggregation.
Right.
So so that's, again, on the file creation side of things. I don't know how much is that known, but yes, that's another issue to be aware of. Again, the same net effect that you are aggregating internal metadata closer to each other, and then you read it in a smaller number of reads, bigger amounts of internal file metadata, so that the chasing, you know, this B node, the B tree that Quincy was talking about earlier, is faster because it's now only in memory, or bigger parts are in memory. So again, trying to act like a interested user. So do we know roughly the breakdown on the number of groups that or links per group where these things are kind of going south unless these kind of interventions are done, or this is really difficult to estimate at all? I mean, in this case, someone, I think, who reported this kind of hit the 410-ish thousand.
So that looks like yeah, that looks like it's hitting the metadata. I think it's a 10 megabyte limit for the old style groups. And yeah, it's so, as I mentioned, it's storing the link names essentially in a block. So the number of links you need to hit this threshold depends on the length of the name. So if it's very long names, then it could be a relatively small number of links. And another thing, I found the code where it initializes the size of the type 2 B tree. And it looks like for groups, at least, it's basically a fixed size is calculated based on the name, the record length. So it's not I don't think it's a user adjustable parameter, at least not right now. That could be potential for an enhancement down the line.
Yeah, I just found that too, and I agree with you.
All right, 2 independent confirmations. That's that's enough scientific fact.
You turn off the parameters on the new style file format. Well, if you turn that on and you do some work to make the metadata blocks bigger, I've seen people get scalable results, like over 1 million links in a group. That's not bad.
It's not bad. I mean, for me, but there's always someone who decides to have a bit more. Yeah. So, all right. Anyone in the audience, so to speak, wants to chime in with question or, ask for some clarification? Or wants to say, we really like having a lot of groups in HDF files. That's also allowed. That's fine. All right. So I think we kind of covered this question enough in this format, with conclusion that yes, there are some things that can be done, but there's also room for adding some new setting that could or new API to the library that would allow these settings to be even more adjusted and configured. The next one, as I mentioned, is this dataset cache business. And I'm also very interested in these issues because, especially when it comes to accessing HDF files in the cloud, there is essentially a recommendation that the chunks are bigger, even on the order of 1 or 2 megabytes or something like that, and that goes above the default dataset chunk cache of 1 megabyte or megabyte. Sorry, megabyte. And now with this AI training situation, if it's really true that the problem is too many open data sets at any one time, which again I'm not quite sure, because there's a lot more questions that I could think of to really say that this is something that the library needs to handle, or at least that it's a library's problem, so to speak. Because again, this seems to be from Python. There are many other issues unresolved here. But generally speaking, from the library perspective, here is what I understand, so correct me if I'm wrong. The dataset chunk cache is initialized when the dataset is open. Is that correct? Not before.
That's correct.
All right. And it always goes to the size of the chunk cache. It's not like I can grow up to a size, but I'll just grow as slowly as people are reading the chunks, or it's always reserves its size.
The size is the maximum size, so it starts out as just small metadata structures in memory.
Okay, so it kind of grows up to the maximum size that you specify. Right. Okay. And so here comes the other question. So it goes away, the memory is freed when the dataset is closed. Is that correct?
So the chunk cache is destroyed and all the chunks are evicted from the cache. Whether the memory is freed depends on your definition of freed. So we have this facility in the library called the free list, where it tries to avoid thrashing the system memory allocator, and it can be turned off at configure time, compilation time, and but so most or all of the metadata structures in the chunk cache are allocated on the free list, which means that when they're freed, they're stuck. The memory isn't actually freed with the system free. It's stuck in a list that's maintained internally by the HDF library. And also, if you have a unfiltered data set, so if data set that isn't compressed or checksummed or anything like that, then the raw data chunks are also put in the free list. So in that sense, then memory that the data chunk cache uses may not be freed when you close the chunk cache. Now you can put a limit on the size of the free lists, and like I mentioned, you can also disable them entirely. But that is one possible way that you might be seeing some data sticking around even after you close the data set. Now, the free list size is global for the entire library. So you're not going to get into a situation where you open 1 million data sets and then all of a sudden you're using 1 million megabytes of RAM. It's still limited. It's something like 32 megabytes or something, if I recall correctly. Don't quote me on that, but it's around, it's not a huge amount of memory that is the default free list size. But it can, if you're looking closely at the memory usage, then that might be why you're not seeing the memory usage drop as soon as you close the data set.
Yeah, but it'll drop pretty soon because it'll garbage collect if it's over the threshold.
Yeah, once it gets over the threshold, then it'll free until it gets down. It frees. It doesn't free everything, right? Or
No, it
just
checks
goes down
everything on the free list. It's like,
oh, right.
yeah, and you can
But
also
what is
call
the
the
threshold
garbage
then?
collect command, right? H5 garbage collect. If you
Right.
really want to make certain that it gets freed now, you can do that.
And so what is the threshold when that freeing happens, if I followed correctly?
It's configurable, and I don't remember the exact number. It might be 32 megabytes or somewhere around there, but I would have to go look.
Is there a function for that?
Yeah,
There is
there's a
a
function
get,
to it.
yeah.
Do we know how that? I don't know. Actually, can we do this search more better than this? H5 is it H5P or something else or
No,
D?
it'll be plain.
It's just H5.
Yeah.
H5. I see underscore.
No, it's API,
Yeah.
so it has to start with.
Yeah, that's what I was thinking, but I don't know what is that clean.
Well, the
Yeah,
garbage collect.
garbage. Yes, okay, garbage collect.
That one, and then the other one I think is just called get free list size or something similar. Well, you got it right there, just at the bottom of your screen.
Yeah, okay. Oh, there's below it. Oh, yes, good. And this one. Interesting. So coming back to the question, so there could be a potential, at least scenario, that if this person's application was really going through million data sets and opening them and reading, and I think in his original question, the user reported reading about 60 what he calls slices, but I would interpret that as chunks. So about 60 chunks from each file, from each data set, that there could be a potential where essentially the library keeps the memory to itself, not really freeze it to this, release it to the system or something. And so maybe this out of memory error is not so far-fetched scenario then.
Maybe.
Is he closing the data sets?
Well, that's a big question. I mean, again, with Pythons, and people usually have these kind of special classes that they create. Again, I'm just guessing. There's a lot of information here that needs to be, more precise. I agree, but that's something that I don't know. I cannot tell for sure. Some people have these long-lived Python objects, which then again prevent from the HDF5 library of closing this data set, for example.
It sounds more like probably like a dangling identifier or something. You could use the, what is it, Neil? I don't remember. H5F get object open IDs or something to see if there's anything dangling around.
I know that H5F is pretty paranoid about having this problem. And so they try to do their utmost to never ever have a dangling identifier, or at least to be very much in sync with the library, with the life cycle of these identifiers. But again, as I said, there is a lot of this kind of information that this user has not provided. But I thought that, again, because of all these unknowns and the Python being involved and all that, I thought that we just revisit from the library side of things what happens. And hopefully that's, at least clarifies some potential problems that might come. But this one actually,
I was going to say, I looked up the limits for that get free list sizes. It has these 4 different types of things: regular, array, block, and factory. And regular is set to 1 megabyte. Array is 4 meg. Blocks are, which is I think where the dataset chunks go, 16 meg. And then the factory one is also 16 meg. So at an absolute maximum, there might possibly be an extra 37 megabytes used by the library before it hits and goes off to garbage collect. But that's not very much these days, really.
No, it's not. It's just that, again, this case is that it looks like it's 1 million data sets. So it is a lot of data sets being opened, and then the caches are being used. And I'm pretty sure because 60 chunks of this size, let's say, assuming it's float 32, it's more than 1 MB.
Yeah.
So definitely, I would assume that the chunk cache is definitely 1 MB.
Yeah, he's probably holding them all open at the same time, and then wait on the memory being used.
Yeah. So basically, for users, I would say the recommendation is that yes, it really does happen to close the dataset whenever you don't need it anymore, and that and also to think about this function. And I'm not sure if these two have any that they are actually available from H5Py. I have to check that. But that might be something also to have for those users who really need to go that deep to squeeze every bit of performance and capabilities from the library. And again, for especially get free list sizes, fairly recent. I mean, not fairly recent, but I know people who are still at 1.10.4 library. So that's why I'm saying fairly recent. Yeah. So
only 12 years old or something.
Yeah, I know, but don't ask me. Yeah, don't. Let's not start another of my rants about that. How people are so lazy to upgrade the library. So yes, I think anything else, Neil or Quincy, you would like to mention here about the dataset chunk caches?
Yeah, no, not right now.
All right. Well, anyone, any questions from the audience?
Alexander, on your description of your talk, the last bullet point that you listed,
yes,
any scenario where the library would somehow keep memory of a destroyed chunk cache around for later use. Did we cover that?
Yeah, that was a free list stuff.
Okay. So, but the answer to that question is that's the only scenario when it gets stuck on the free list.
I mean, unless you count like the systems, the file system cache.
Okay. Yeah. We wouldn't. I wouldn't count that. Okay. All right. Thank you.
Yeah. All right. Well, if no more questions and no questions from the audience, some other HDF question, then I would say we are done. Thanks, Neil. Thanks, Quincy. This was really helpful.
Thank you.
And thanks, everyone. And off to next week when someone else will have this session. Take care.
Thanks. Bye.